We are all mature solar observers here, and when it comes to coronal mass ejections aimed at Earth, there are some serious topics. You know about earthquakes and severe weather, and the truth is that nature can throw a lot of hardships at us. Now, the sun cannot zap you or melt you with the CME, but our way of life has caused humans to be vulnerable to these solar eruptions in a way that humans have never experienced in the history of our species. The following is the first few minutes of a presentation from 2013 called How to Watch the Sun. It begins with what happens once every few hundred years, in a worst-case scenario. Our star somehow found itself the punchline of cheesy science fiction. Dramatic doomsday events like the ones in Knowing in 2012 are indeed fabrications of Hollywood sensationalism, but there's nothing fictional about the potential for the sun to change our way of life. This wasn't so true when there were 13 colonies, or when Babylon was Sumer, or when we lived in caves, but it's true now. We have partly brought that on ourselves. Could you imagine if there was suddenly no electricity? Suburban and rural residents would see the auroras well before the lights go out, but city living would leave you to watch the heavens warning as consolation in the wake of disaster. No water from the tap, no phone. Within 48 hours, no gasoline, no food at the store, no end in sight for weeks, months, or longer. The last time something like this happened was 1859, the Carrington event, at the dawn of our electric age. A massive solar storm set fire to telegraph offices and shocked operators. There wasn't much else to destroy. Smaller bursts of damaged satellites have taken out electricity in Canada and Sweden in the last few decades. We haven't seen the big one again, not yet. Megaflares have lit the skies many times throughout human history and posed no direct threat to us. But now, unlike the past, humans are uniquely vulnerable to a megaflare because of our dependence on electricity. The more dependent we become, the more vulnerability we face. Some experts say destruction could top $2 trillion, others say more. And some say there is a 10% chance of seeing such a blast in our lifetime. There are tens of thousands of us watching every moment of the sun, and if you so choose, you will be able to do it too. Why do we watch the sun? Because the mega flare is an unlikely yet ever-present possibility. Before learning more about our star, we need to understand just how it interacts with our planet. Our planet came with a built-in invisible defense against energy from the sun and the galaxy. Our planet forms a complex magnetic field around itself. It is our protective interface with energy from space, our shield, known as the magnetosphere. And this is no conspiracy. The magnetic field is fading. Many sources, including the World Center for Geomagnetism in Kyoto, Japan, have simple visualizations of our magnetosphere. This one shows it weakening over the last 400 years. As of just a few years ago, the field had decreased 10% since the 19th century, and it's hastening its shift. This makes Earth more vulnerable to megaflares from the sun and galactic radiation. There is no evidence to suggest that the field would ever disappear completely, and evidence does suggest that humans have endured such events many times in the past. However, with our electric way of life, one cannot help but ask the question, how much weakening before the sun could easily take out our power? These megaflares happen anywhere from 100 to a few hundred years apart, so 154 years after the Carrington event, that aforementioned 10% chance of seeing one in your lifetime comes into perspective, along with just how lucky we've been in our electric age, and just how important it is that we watch the sun.